In this video, we're going to talk about simplifying expressions that contain negative or zero exponents. So the bottom line has to be with when I have something like this, x to the negative a, something like that. That becomes the same thing as 1 over x to the positive a. And if it's in the bottom of the fraction to start with, like 1 over x to the a, x to the negative a, then that would just bring it back. This whole thing would come to the top of the fraction as x to the positive a over 1, so that would be it. So that's kind of the main rule we're going to use. Now we're going to use that with some different problems. So I'm going to show the first one here. We have some negative exponents in our fraction. So I think the best way to do this is to make a new fraction. And what I do is I take each item in here, the 2, the p to the third, the r to the negative fourth, this negative 6, the p to the negative 2, and r to the negative 3, take each one separately and either leave it where it is on top of the fraction, on the bottom, wherever it is, and then move it if it has a negative exponent. So I'll start with the 2. So the 2 is a positive exponent, so that's 2, because that's 2 to the first. And p to the third, 3 is positive, so that's p to the third here. And r to the negative 4, since that's a negative exponent, this thing will come down to the bottom of the fraction. So on the bottom, I'm going to put r to the fourth, positive. Now the negative 6 is, the exponent is still 1, so that's going to be a 6 on the bottom of the fraction. P to the negative 2 has a negative exponent, so we're going to move that one up to the top as p to the positive 2. And r to the negative 3 has a negative exponent. That's going to move to the top as r to the positive 3. And what we've done is just rearranged it a little bit so that none of the exponents are negative. And now the last thing to do is to simplify this. So we're going to make another fraction for our answer. And we deal, first of all, with the coefficients, 2 and 6, and that can be reduced. Excuse me, that's negative 6. 2 and negative 6, so we're going to reduce that to be 1 over negative 3. And now I look at the p's, and I just take one letter at a time, take care of the p's. All the p's are on the top of the fraction. P to the third times p to the second. We add the exponents there, and that becomes p to the fifth. And then the r's there's some r's on top and some r's on the bottom. There's a couple of ways to do that. What I like to do is ask myself a question logically: are there more r's on top or on the bottom? And since there are more on the bottom, there's going to be r's on the bottom. The question is, how many are extras? There's 3 on top and 4 on the bottom, so 3 of them will cancel out, and I'm left with 1. So there's 1 extra on the bottom. So basically, that's the final answer. We'll clean it up a little bit. These 1s, 1 times p, we don't need to put that. So the simplified form would be p to the fifth over negative 3r. And you'll see it written like this. Sometimes if it's a multiple choice thing, it might be written like this. P to the fifth, that's a 5, over 3r, where the negative becomes the whole fraction. So basically this would probably be the most common answer to see. Okay, the next problem we're going to look at has to do with negative exponents. There's no fractions in here. We'll end up with a fraction because of this negative exponent right here. M to the 0 is kind of anything to the 0 power is 1. So I can look at basically this whole thing here as just being 1. So in essence, we kind of just disappears from our thing here. But let me erase that for now. Okay. So what I would do here, we're going to use the rules of exponents where we can multiply. Negative 5 times 8 is negative 40. What's going on here? Negative 40. M to the first, that's a 1, and that's a 0, so that's going to be m to the 1, or just m. And then n to the 4 minus 4 times 4 minus 5 is n to the negative 1. What's going on here? N to the negative 1. Because we add the exponents, 4 plus negative 5. So that's not quite right because we still have a negative exponent. Next thing I'm going to do is make a fraction out of this. The negative 40 has a positive exponent. The m has a positive exponent, and the n has a negative. I move it to the bottom, and that's going to be my final answer right there. The next problem Okay, this is what they call the power of a power. And basically this exponent will distribute to each exponent in here, because this is outside the parentheses, and we multiply the exponent. Now, what people will often forget is that there's an imaginary 1 right here, 6 to the first. So that would mean it's going to be 6, and then 1 times 2 is 2. And then we have x, and we multiply negative 3 times 2 and get negative 6. And then y, there's also a 1 here that's not written, so y to the second. And then z, and then 7 times 2 is 14. So that's the first step. And then what we want to do is take this and put it into fraction form, because we have a negative exponent. So a negative exponent, we're going to put 6 to the second. I can write that as 36. X to the negative 6 becomes x to the positive 6 on the bottom. And then y to the second, and z to the 14th. And that would be my final answer for that one. All right, next problem is similar to this. Well, actually, it involves both types of things. First of all, we have to deal with this parentheses and this 3, and then we're going to deal with the negative exponents. My suggestion is don't try to do everything at once. Just do one thing at a time. First, we're just going to take care of this mess up here. So again, just like the last problem, the 3 multiplies to each exponent. Now there's a 1 there, so that's going to be 2 to the third. M to the 4 times 3 is 12. N to the negative 6, negative 2 times 3. And the bottom we're just going to leave just as it is. M to the negative 2, N to the negative 4. And now I just go through the next step. What we've done is taken a complicated problem, turn it into an old one. This is similar to number 1, or 2, I think it was 1. And we'll make a new fraction out of this. I'll do this down here. 2 to the third, that's 8. M to the 12th is a positive exponent. Leave it where it is. N to the negative 6, since it's a negative exponent, move it to the bottom as a positive 6. And I'm just taking each number one at a time. And now I go to this one. The negative is going to stay down at the bottom. Now be careful, this negative is not being squared here. The negative is kind of like negative 1 times that. So I'm just going to leave this as negative 1. It kind of makes this, if this were in parentheses, then it would have to do with the 2, but it doesn't. People often square that and think negative squared would be positive, but this negative is not squared. So it stays as negative 1. And then the m to the negative 2 goes to the top as m to the positive 2. And then n to the negative 4th goes to the top as n to the positive 4th. So now the next and final step would be to take care of all of the things. So the 8 and the negative 1 just becomes, I can write it as 8, or I can put negative 8 in front of the thing. I'll just put a negative right there for the negative 1. M to the m's, all the m's are on top, so that's going to be m. I add 12 plus 2 and get 14. And n's, there's 4 on top and 6 on the bottom. My thinking is there's more on the bottom, and there's how many more? There's actually 2 extras on the bottom, so that would stay on the bottom like that. And this would be what my final answer is. If you wrote it like 8m to the 14th over negative n squared, that would be good too, but this is probably better.